So we just talked about antiderivatives and what they are, and now we're going to start learning how to find antiderivatives. And just like we did with derivatives, we're going to start off with some very basic ones. And in Calc 1, we actually won't get too far, and you'll learn more in Calc 2. So on this side, we have our function. So just kind of the function you're starting out with. And on this side, we're finding its antiderivative, or a formula for it. And you'll notice, to find the most general one on each of these, you would want to put a plus c. So I didn't write a plus c all the way down. You'll just remember that if you're doing this, you'd put a plus c. Okay, so we'll put little examples under here to help explain. So if you have x to the n, now remember the derivative formula was that you multiplied by the power and then subtracted one. We kind of need to do opposite of that. So what you do here is you actually add 1 to the power, and then you're going to divide or multiply by 1 over that power. So example, if we have x cubed, we're going to raise that to x to the 4th, and then we'd have 1 over 4, 1 over that new power. So raise the power, divide by the new power, right? This is the same as x to the 4th over 4. Oops, not over x. Over 4. Okay, and then of course you'd put plus c. Okay, if you just have a, where a is a constant, so for example 5. Well, the thing that just gives us a derivative of 5 is if we have 5 to the x. So we'd have 5x plus c. So if you just have a constant, the antiderivative of it is that constant times x plus c. And what you can think of this is like 5x to the 0. Because x to the 0 is just equal to 1. So we're saying raise that power to 1 and divide by 1. Okay, just like derivatives, if you have a constant out in front of a function, so here we could say something like 5x cubed, you're going to kind of leave that 5 alone and take the antiderivative of the x cubed. So we'd have 5x to the 4th, we raise the power, and then we divide by 4 and put our plus c. If you're adding two functions, you would just add their two antiderivatives. So if we had something like 6 plus x to the 4th, then the antiderivative, we'd make it 6x plus x to the 5th over 5. So we would just take the antiderivative of each part. Okay, like we talked about, the antiderivative of e to the x is e to the x. Here's one we have to be really careful of. If we have 1 over x, the antiderivative is natural log of absolute value of x. And we have to put that absolute value in because the x here could be negative, but when you're taking the natural log of negative numbers, you can't. The domain of natural log is 0 to infinity. So here we need to make it natural log of the absolute value of x. The antiderivative of a to the x is a to the x over natural log of a. So example, if we had 2 to the x, our antiderivative would be 2 to the x over natural log of 2 plus c. Okay, then we have some of the basic trig functions. So the antiderivative of sine is negative cosine, and the antiderivative of cosine is sine. And this is where you have to be very careful, because this is opposite of when you are taking derivatives, right? So at this point in a course, students normally start making tiny mistakes because they forget whether they're taking a derivative or an antiderivative or which rule. So you have to be very careful. When you're taking a derivative of sine, it's just cosine. But when you're taking the antiderivative of sine, it's negative cosine. Okay, and the antiderivative of secant squared is tangent, because if you take the derivative of tangent, it's secant squared. Okay, and we'll have more of these later, but if you have the antiderivative, this one seems really odd to put on this list, but 1 over the square root of 1 minus x squared, well, the antiderivative of that is sine inverse of x, because the derivative of sine inverse of x was 1 over the square root of 1 minus x squared. Okay, one that we also see come up a lot, if you have 1 over 1 plus x squared, the antiderivative is tangent inverse of x. Okay, so we're going to find the general antiderivative for the following functions. So here we have x squared plus 5, so our big f of x We add 1 to the power and divide by the new power. Plus 5x, and then we'd say plus c. Okay, number 2 here, we have f of x equals cosine of x plus e to the x. So our big f of x, the antiderivative of cosine is just sine of x, plus the antiderivative of e to the x is e to the x plus c.